All right, here we are. We're wrapping up chapter 24, which is on comparing means or finding the difference of two means. Okay, so we're on chapter 24, quiz A, question number 2. So in question number 2, they ask us to create and interpret a 95% confidence interval. We all know that the general form of any confidence interval is estimate plus or minus margin of error. But before we get to that, let's review some of the information we learned from question number 1. Okay, so first we learned that the observed difference is 0.432. Okay? We also learned the value of the standard error. The value of the standard error was 0.185. Okay? So we need this information to move on, so I figured I'd put it up here for you to look at. Okay, so let's take a look at the general form of any confidence interval. Here we go. Estimate plus or minus margin of error. Okay? So our estimate is the observed difference plus or minus the critical t-score for a 95% confidence interval with 19.44 degrees of freedom. That's also something we got in question number 1. We know the degrees of freedom is 19.44. And the standard error is given up above as 0.185. So plug it in, plug it in. So let's plug in what we know, and I'll just review how to find this critical t value. Okay, so we have the observed difference. We have the standard error. Let's take a minute and figure out how to find this critical t value again. Well, let's take a look at a 95% confidence interval. Here's a rough sketch of a 95% confidence interval. Okay, we have 95% of the curve underneath, and then we have 2.5% in either tail. That means if we were looking at the critical t value right here, that critical t value would actually be 2.5 plus 95, or 97.5% of the curve. Okay, so that's going to be important. So for us to get the critical t value, we need degrees of freedom. Again, we know in the last problem we calculated the degrees of freedom as 19.44. So let's take a look. We're going to use our inverse t function. Here's the area under the curve, 0.975, and comma, remember always degrees of freedom when you're talking about a t distribution. So we plug into our calculator. Let's all do this. So second vars, arrow down to inverse t, and it's 0.975. That's the area under the curve. And 19.44 is our degrees of freedom. Hit enter. And we should get approximately 2.09. Let me get this out of the way. Again, so our critical t value for a 95% confidence interval with 19.44 degrees of freedom is approximately 2.09. So we're going to plug this value back into our equation over here. I am getting better at this. I know you guys think so too. Okay, and here we get 0.432 plus or minus 2.09. That was our critical t value for a 95% confidence interval with 19.44 degrees of freedom times 0.185. Okay, so the rest we can do in our calculator. We then get 0.432 plus or minus 0.387. And then finally, we get our confidence interval. And I did see on our last test some people weren't writing their confidence intervals correctly. It's obviously lower bound, comma, upper bound. They should be written in parentheses with a comma in between. And so now we can draw a conclusion about this confidence interval. And our conclusion would be we are 95% confident that the mean GPA for college women is 0.045 to 0.819 points higher than the mean GPA for college men. Okay, let me say that again. We are 95% confident that the mean GPA for college women is 0.045 to 0.819 points higher than the mean GPA for college men. Let me see if I can type that out real quick. I don't know how I missed that. Let's see, here's our conclusion. Let's see if I can type it down here. Does it let me type while I'm working? You never know. Ah, look at that. I always get excited when I find a new button that works. Okay, let's see. I'm a terrible typer. I don't know if I'm as bad at typing as I am at spelling. Voila, success. Okay, so again, here's our conclusion. We are 95% confident that the mean GPA for college women is 0.045 to 0.819 points higher than the mean GPA for college men. And I am finished with Chapter 24, Quiz A, question number 2.